Okay, we're going to continue to factor polynomials, but this time we have some special situations. We have a difference of two squares, and there's only two terms in the polynomial this time. So let's see what happens when we factor these. I know that in the upper left-hand corner I have to put my x squared term, and the lower right-hand corner goes my constant term. And x times x is what gives me x squared. 3 times 3 gives me 9. In order to get a negative, though, I'm going to need a negative and one positive. And now let's see if these other corners are going to add up to give me what my middle number is. Well, 3x and negative 3x add up to 0. My middle number, there is no middle number in this polynomial, so that middle number must be 0x. So that means that my terms in the on that diagonal do add up to exactly what they have to add up to in the middle. So that gives me factors of x minus 3 times x plus 3. And I could switch those around. I could say x plus 3 times x minus 3. It doesn't matter which order I put them in. So again, in the next example, I'm missing a middle term. So that must mean it's x squared plus 0x minus 25. Some of you might already be thinking what the answer might be. So I can put my x squared term in the upper left-hand corner, my constant in the lower right-hand corner. I know that x times x gives me x squared, and I know that 5 times 5 is what gives me 25. Since I need a negative, one of these will have to be negative, one will have to be positive. And the two terms on the second diagonal should add up to 0, which is my middle term in the original problem. And they do. So my factors for my answer are x minus 5 times x plus 5. And again, I could switch the order of those around and I wouldn't have a problem. Some of you might already see a pattern to how the answers or how the factors in the answer look. They basically are both the same variable in the same spot, and then the same numbers that are used. Now, in the first example, I used 3 and 3 because that's what I multiply to get 9. In the second example, I used 5 and 5 because that's what I multiply to get 25. Third example, I must need to use 6 and 6 because that's what I multiply together to get 36. And one has to be positive and one has to be negative. So exactly the same factors except different signs. Same thing is true over here, even though I have a number in front of x squared. I need to know what do I multiply together to get the 25. So 5x and 5x. Then I have a 7 times a 7. One will have to be positive, one will have to be negative. And in case you don't think that that works, you can always write a factor box or a multiplication box. I guess when we're multiplying, it's a multiplication box. And when we're factoring, it's a factor box. It's the same thing though. You can always take the two factors that you have and multiply them together and check to see if you get what you need. So upper left will be 25x squared. Right here will be a positive 35x. Here will be a negative 35x. Those will give me 0. And then a negative 49. So 25x squared minus 49 is exactly what I had started with. Some students want to assume that if this works for a difference of two squares, it'll also work for a sum of two squares. So let's give that a try. X squared plus 16 instead of x squared minus 16. And I know I need an x squared and a positive 16, x and x. 4 times 4 is what gives me 16. In order to get a positive, though, they both have to be positive. And this adds up to 8x, for a total of 16x in the middle, which I do not have in my original problem. Okay, if it doesn't work for positives, then they say, well, maybe it works for negatives. So let's give it a try. Instead of using a positive 4, let's use a negative 4 here and a negative 4 here. Well, the only thing that does is change this to a negative 8x and another negative 8x, and that's going to add up to negative 16x. So it is not possible to factor a sum of two squares. You can only factor a difference of two squares.